All right. Hello, everybody. Welcome to another episode of React Wednesdays. My name is TJ Van Tol. I work as a developer advocate at Progress. And with me, as always, Dan Wilson. Dan, how you doing today?
Doing good. I hear it's baseball season, so I wore my Springfield Isotope shirt. So I'll
I
rep the
got,
hometown team there for the Simpsons.
I got, yeah, I got the Tigers on. Our Michigan sports teams lately. I don't want to really talk about it. We lost the Wolverines from the basketball tournament last night, so it's rough going.
I hear beer helps.
Dan, you want to tell people who you are, what you do, that sort of thing?
Yeah, I'm Dan Wilson. I work with Digital Primates. We do enterprise React consulting, and we curate the enterprise React newsletter, which is how I heard out about Recoil. So if that's your kind of thing, subscribe. We'll never sell your email.
Well, cool. And if you are new here, this is React Wednesdays. This is basically a show we do every Wednesday, as the name sort of implies. We bring in cool people from around the React world. We have them show us something awesome. So in a minute, we're going to welcome in Dave McCabe to talk to us about Recoil. But just so you know about some upcoming episodes, we're going to have Fred Schott. Hopefully I'm getting that right. Talk to us about Snowpack next week. So I'm pretty excited about that. Snowpack is an interesting tool to me. We got some advanced TypeScript stuff coming on later this month, and also some stuff with React context. So always interesting stuff. And if you want reminders for all of this stuff, you can add React Wednesdays to your calendar. There's ways to add individual episodes and such and whatnot. So it's telework.com/React-Wednesdays. So that is React Wednesdays. But for today, I want to welcome in, because we want to talk about Recoil. And for that, I'm going to welcome in Dave McCabe. Dave, how are you doing?
Good. How are you doing?
I'm doing all right. You want to tell people who you are, what you do, all that good sort of stuff?
Certainly. So, yeah, my name is Dave McCabe. I'm a UI engineer at Facebook based out of their Seattle office. Been working there for about 5.5 years now and worked on a bunch of different things, mostly to do with performance tooling. So profilers, data visualization, that type of thing. And kind of a Recoil kind of spun out of that work and decided to open source it a while back. So yeah, pleasure being on the stream and talking with you both.
Yeah, so maybe for people that have not heard of it before, could you give like the world's simplest definition of what Recoil is?
Sure. Recoil is a little extra ingredient that you can add to React to handle a few things that it doesn't do well by itself. The main one being what I call leafy state, which is state where it affects two or more leaves of a tree rather than a whole tree, right? Distant leaves. You've got two things that are in different places in your UI that need to be in sync. And the basic assumption of React is that most updates are either small or big. Like you're either going to a different screen and you need to re-render everything, or you're just like updating a little button or something. Like almost all updates in most UIs fall into those two categories. And so React can handle those efficiently. But when you've got things that don't fall into that, sometimes you can run into problems. And so Recoil is trying to address those in a way that's like, well, speculatively, if we didn't want to create a whole different system, but just like, what if React had an API for doing that? What might it look like? You know, theoretically, that was kind of the principle of how it was designed. So yeah, I guess that's it in a nutshell.
Yeah, and it's funny because we live in a world where there's seemingly new tools coming out all the time, right? There's always a new JavaScript tool or utility, and it's not very often that one sort of instantly clicks with me. So I remember when I first saw your talk about the API, like it instantly resonated with me. Like, oh, like, yeah, there's those little state problems that are just annoying to deal with because you have to figure out some way to pass it around. And I thought Recoil sort of solved this elegantly, and it's gotten like I hear about it all the time now. I'm curious, did you expect when you put this out for this to just resonate so well with the community, or did it sort of take you by surprise?
That's a good question. I appreciate you saying that. It did. Well, I guess I didn't know what to expect exactly. Like when I look at it, I mostly see the things that are deficient about it, or like reasons you might not want to use it, you know. And so, but it's cool to see that it's actually useful for people, you know what I mean? Which I think is the test. So like empirically, is this helping solve people's problems? Does it fit in with people's minds easily? And it seems like that's the answer to that is yes for many cases. So that's been really cool.
That mindset is like the creator mindset. You create something beautiful and you see the imperfections, but other people see the beauty.
Yeah, I think that's definitely a real tendency.
So I definitely have some other technical questions, but maybe now is a good time to just jump in, because I know you wanted to show a little bit of this off. Maybe we can take a look at what some of this looks like and then go from there.
Yeah, maybe just real quickly, just so everybody kind of knows what we're talking about. So I'm going to share my screen and just do a quick demo to give you the basic idea here. Turn on screen sharing. You get a nice hall of mirrors or something. Is that working yet?
Yeah, we can see the go
All right,
behind the scenes here.
So I can't see you, so just speak up if you need to stop me here. Okay, but here's the basic idea. Suppose I have a drawing app, so I can draw some boxes and edit some things and that kind of thing, move some stuff around, whatever. Put some things on the canvas. And the way that you might model this as you see it in React is that you would have a canvas component, and it would have some state that's got the list of items that are on the canvas. So it would have like an array with 2 things in its state. And then you'd render out a component for each of these items. And then they would have local state for their like position, label, that type of thing. So let me switch over, and I've got some example code. So if you imagine you have the app, you've got this like set of item IDs in its local state, and then you just render those items out. And then in each item, they've got some local state that has their, you know, specific information. And the reason that you would want to put the state for each item in that local to that component is that you don't want to re-render everything whenever any of them changes, because that would be too slow. Like you want to just re-render this one guy when you move it around, right? So far, so good?
Yep.
Cool. So the issue comes up when you add some more features. I've got a sidebar with a list of items, and I've got this inspector over on the right. And you'll see that they're in sync. So like when I move this around, the thing over on the right is changing in sync. The thing on the left is changing in sync. And so what you have in a situation like that is a React tree where you've got your root. You've got 2 disparate parts of the tree that have components that need to stay in sync. So like here, if I'm moving item number 2, I've got a component on the canvas for that. And then I've got a component in the sidebar that corresponds to it. So it's like, you know, these 2 components here that need to be in sync, right?
Yeah.
And if the sort of basic thing you do in React to handle that is hoist the state up to their common ancestor. But the problem with that is that then everything has to re-render whenever that state changes, right? So that's frequently going to be too slow, so you don't want to do that. The other thing you could do is put it into a context. So that's a feature in React that lets you have a provider component that's at the top of the tree that has some value, and then components can subscribe to it, consume that value down below. But that falls down in situations where you have a variable number of things. Like as I'm adding things to the canvas, I don't know how many of them there are. And each one of them should have its own context provider, because otherwise, you know, it's the same situation as with just putting the state at the top of the tree. And so you have like all these different providers for these different, like one for each item, right? Because they need to be separate. They need to update separately. But you run into problems where you want to insert. So like if you add one, if you're going to add a new node onto the tree here, that actually changes the shape of the tree. So React would have to unmount and remount that entire tree, right? So that doesn't work. And in addition, it introduces a coupling if you're using context providers to do this kind of thing, where you have to know at the top of the tree that you're going to need the state down below. So you could have a situation where like maybe some state is associated with a plugin or something like that, where when you're at the top, you don't even know that that thing exists. You don't know that you're going to load that plugin or whatever, but then 2 different things need to talk to each other. So it'd be nice if they could just collaborate without involving the thing that's at the top that may be totally unrelated to them, right? And so what we'd like to have is something where you can kind of have these independent pieces of state that these components can refer to, and each one can have its own like separate piece of state that updates, and you have them all going at once, and you don't need to involve their ancestor in the React tree. So that is the thing that we want to provide with Recoil. So does that make sense so far? And I'll go into kind of how that code would look if we wanted to change this, the code that I showed before to use Recoil.
It does, and I want to give you a quick shout out. I love your slide design of the
thanks.
like the like three-dimensional nature of the state, like breaking out of the. It's a nice like visual metaphor for how that works.
Appreciate that. And the drawings are this really cool tool that a colleague of mine, Christopher Shadow, made called Excalidraw.
Oh, yeah.
And if you go to excalidraw.com, it's free, it's open source, and you can start drawing, and it does it in this like freehand style, which actually makes, like if I was to draw this, it would look really bad because it would, if something's really precise, it aesthetically relies on like perfection, but if it's sort of squiggly, then it doesn't, and it gives it a nice flair. And it's also just a very fluent user interface that's really quick to use and is a great substitute for drawing on a whiteboard, that kind of thing. So it has collaborative editing.
Yeah,
so
I can't think unless there's a whiteboard in front of me.
Yeah,
this is great.
If you need to whiteboard on the internet, there's nothing better than Excalidraw, actually. So
yeah,
but anyway, go ahead.
I was just going to say, I think your example makes a lot of sense. And also, like, I think, like, and you even include this as like a simplified example, right, to prove your point. Whereas the reality is most of us are building complicated apps where there's these pieces of state are all over the place, right? And like our trees, there's not just like 2 trees, but there's like 8 or 9 trees, and there's things all over the place. And sometimes keeping track of where your state should go, well, not only allowing you to code, but also like the performance implications, like worrying about re-rendering, it can quickly turn into a hot mess. So
yeah, it can. I mean, it really depends on the app. Some apps are really well suited to the React model where things are just nested within each other, you know, and that works fantastically. And there's a lot of advantages to that. So yeah, it just kind of depends on the app, but it can get pretty complicated for sure.
Yeah.
So just going back to this example, and this will just take another minute or two, we need a name for these types of little pieces of independent state, and we're calling them atoms. So each of the components on the canvas will have like a separate atom that contains its state. I want to do a more simple example though, just to show the API. So I have this background color, and I can change it to whatever color I want. And so I've got a situation where there's this picker over here in one part of the tree, and then this like backdrop in another part of the tree, and their state needs to be in sync. So if you imagine having 2 different components, the color picker and the canvas backdrop, and they each have local state, and we want to put them into sync. So the question is like, can we have an API that's just very similar to the React API? You use state, but they're talking about the same state. Like these 2 components are referring to the same state in some way. And so we can do that. We need to have something that we're kind of passing into both of these components to tell them what state they do, what state they're looking at. And so we'll just import something called background color from some module. So they're both getting this thing that's like a pointer to some piece of state. And then we just change use state to a new hook called use recoil state. We pass in background color. So background color is this atom that represents that piece of state. And then once we do that, both of these components are looking at the same state. And when you call set color on one of them, it's like it also calls set color on the other. So that's sort of the model. It's like they both have as if local state, but when you set one of them, it's setting the state of every component that is looking at that same atom. Does that make sense?
Yep.
And so how do we define background color? It's an atom, and it just needs a couple of options. One is a key, which identifies it uniquely, and then just like React state, it needs a default value. So we give it a default value, and then we have this background color that's sort of sitting outside of the hierarchy and flowing down into both of those components. Although something I'm leaving out from this diagram is that we don't really want this to be global. We still want to be able to like constrain it to a particular React tree. So there's a special context provider called Recoil root, and background color is really living inside the Recoil root. And if you could have like a separate copy of the app or something as a separate value for background color. So the thing that you're defining and exporting here is like a pointer to some state that's in this special context. There's no value inside of this object, if that makes sense, right?
Yep.
So you still get the kind of encapsulation and separate, all that type of thing. And the updates are scheduled through the React scheduler and all that type of thing. Okay, so that's how we would do a single one, but we could actually just do that with context. So let's do the one where there's like an indefinite sort of family of these different atoms. There's a different atom for each of the components that's on the canvas. As before, we had this canvas item and currently has some local state. We want to change that to look at an atom. So we need to change that to use recoil state, and we need to like pass in a different atom for every component, because each component has its own independent state, right? So it has an ID. We basically want to go from an ID to an atom, right? So that each ID gets a separate piece of state. And so we'll just define a function that takes that ID and returns an atom. And we can put in some stuff, whatever the default value should be. We'll memoize that function so that each time you give the same ID, you get the same atom. And then this is such a common pattern that we actually have a utility for it in Recoil called atom family. So this is a family of atoms. We've like distributed all the ID argument down into each of the options here. But it's just a memoized function that gives you a different atom every time you give it a different ID, or it can be any type of parameter.
Yeah, there's about 10 jokes for the atom family here.
I know, yes. You gotta enunciate that very carefully. Atom family. So, but yeah, your code can definitely be very scary when you start doing this type of technique, no doubt. So we'll just take that atom family and export it as something called item with ID. So it's a function that takes an ID, gives you the atom for that item. And then that's what we would put in that component. And so once we have that, we have this picture where there's these different atoms. There's one for every ID, and then these corresponding components are just subscribed to the one thing. So when I move this around, like these two things re-render, but all this other stuff that's on the screen does not re-render. Okay, so far so good.
So the ID points to this memoized object, and you can use the ID where it makes sense and get a reference to that exact pre-computed object stuck in the state. Is that kind of right?
Yeah, and so you can split up your state into all these different little pieces, these different atoms, and each one, when you update it, it just re-renders the specific components that actually need to know about that one thing. And the cool thing about in contrast to some other systems, you're kind of manually like decomposing your state into things that are sort of in this like normalized form where you're like looking it up from an ID and that type of thing, rather than just some magic where there's like an array with special properties so that we intercept that, all that kind of thing. The advantage is that you can actually you can build any data structure out of atoms. So for example, even though each of these individual items has its own state, the canvas currently, as this is written, still has just this one list of all of the items that exist. And so it has to re-render when you insert an item. And that could potentially, you basically inserting the item is going to be O(n). But if that was too slow, you could like implement a tree data structure or something like that instead of just a flat array, or any type of data structure you wanted, and compose it that way. So it kind of allows you to escape in situations where there's a real performance issue. You can kind of build whatever you want out of that block, if that makes sense.
Yeah, it actually, like, one thing I'm curious about, and this might be a good time to bring this up, is I'm curious what advice you have around using Recoil versus, because you had mentioned sometimes like these are some things that are things that context does.
Right.
Do you see advantages in like mixing and matching, like using context where it totally solves the problem, and then only using Recoil where it has like it's uniquely needed? Or do you think there's some benefits in just being consistent? Or I guess what sort of advice do you have about like that sort of mixing and matching?
That's a really good question, because there's situations where, here's what I would say. Generally speaking, you want to just use React if at all possible.
Okay.
If you're only using React, you are guaranteed to be compatible with React future changes. You're going to be able to use whatever features that the React team comes up with, which are often really cool. And there's a lot of cool stuff coming down the pipe. And you just have sort of less risk. React is super high quality software, very, very rare to have bugs in it, in contrast to Recoil or most things that you might want to be incorporating. It's just, it's simpler and there's less overhead. So there's a certain performance cost to using an external thing such as Recoil. There's more overhead to that than just using React. So I would say, if you can, just use React and use Relay for your data fetching too, which is, we can go into that, but Relay is another amazing piece of software. The only time I would use Recoil is if I have no other choice.
Gotcha.
Right. But once you're there and you're using it, there is a huge value to consistency. So I could see the argument that like, okay, I have to use Recoil for this specific app because of the type of interactivity that it's supporting. And so I might as well just kind of use it consistently because I'm already in with 2 feet. I'm stuck with whatever issues anyway, so I might as well just go ahead and use it. That's kind of the way.
So given that,
Yeah,
what would the refactor path look like if someone started with context or another like built-in React capability and then wanted to move into Recoil?
It can be a bit difficult, and the reason for that is scheduling. So if you usually if you're using like say Redux or something like that, you update it and it's a synchronous update. Whereas the way React works and the way Recoil works is that it's queuing that update, and you will eventually be able to read that, but it may be batched with other things, right? And so if you've got your state in say Redux and you're moving it over, if you've got 1 foot in each, you can't do synchronized updates across both of them. Does that make sense?
Yeah, because
like if you need to simultaneously update something that's over in Redux and something that's in React or Recoil and have them happen at the same time, you can't, because the Redux one is synchronous and the React one is like, call you later. It'll happen at some unspecified point in the future. So if you need those 2 things to be in sync, you need to move them together. So that's the main hiccup. But otherwise, you can, barring that, you can just kind of gradually move. There's nothing stopping you from having both going at the same time.
Yeah, your point's a good one.
Some pretty. Go ahead.
I can just certainly imagine some poor developer out there making a move, and he's got both of these systems in place, and there are these little tiny timing inconsistencies, and whatever hair he had left, he's pulled out and thrown it on the desk, and be like, "What's going on here?" So you probably help somebody a lot.
Well, I've definitely been in that situation and come out with some hair intact, but
nice. Yeah, you got gray hair.
It can be very, very frustrating. I stopped cutting it when the pandemic started. I was like, well, this is the perfect opportunity to try the long hair look. So that's been kind of fun.
We find the good in everything.
But I have pulled some out in the exact situation that you're talking about, because we've ported a few pretty complicated apps to Recoil and actually seen really huge performance speed ups from doing that. But it's definitely laborious if you're all in on one system and you want to like move to something else. It's all through your app. That is not going to be easy to do, which is another great reason that if you can just use React, you should.
And you've kind of explained this, but what exactly is the nature of the performance increase? Like, is it the memoized objects in the key value store? Where is this coming from? Is it the synchronization with the scheduler?
It's basically because you're splitting your state into little pieces, and you're only it's just because things are like, the size of the thing that needs to update. So where we've seen big performance improvements are apps that are using something like Redux, where there's a global, you could kind of think of Redux as being one atom, right? And then what you're doing is every component has this function to tell it whether it needs to update. It's like, do you need to update? But here's the issue. It has to actually call and evaluate that function on every component. So it is doing this thing that is pretty fast, but eventually you will hit a limit. It's ultimately it's O of the number of components that are connected to your store, because they all have to at least check if they need to re-render or not. And eventually that gets slow. So like we have an app that is a drawing app. It's like a design app. And I think the P90 document size is like 50,000 items or something like that. People put really complicated documents, and if you're calling that function 50,000 times, even if it's really fast, you'll hit a performance problem. So that's the type of situation where you get the big speed ups.
So if I'm profiling my app and I notice I'm rendering a whole lot, it might be time to move over.
Potentially. I mean, you might be able to just organize your state differently, but what you don't want to do is have a big blob of all the state in one place and just always have to check everything whenever anything changes. That's where you run into problems. But there's lots of ways to get around that depending on the app.
So this conversation segued into what I wanted to get into, and because you talked about using Recoil in like complex apps, and one thing I'm curious is how you organize this, like almost from like a file structure point of view, because your Recoil state like is sort of by definition more global or something that sits out of the individual components. I'm curious, like I mean, maybe this is too simple of a question, but like where do you put that? Like where do you put it so that, like, especially because I imagine in a complex app you have multiple little pockets where you have some Recoil state. So have you found that you have any trouble with developers knowing like, okay, where is this state coming from? Where's this state coming from? Or do you think that it's ends up being fairly logical even at scale?
I think it's pretty logical. What I would suggest is that you co-locate your state with the things that are using it. So for example, if it's only used by two components that are in the same module, just put it in that module.
Okay.
Right. Or put it like nearby, organize things by feature or whatever.
Yeah.
But what I wouldn't suggest, I mean, do what you want, but like you probably don't want to have a separate directory that's like, this is all my atoms, because why is that?
Yeah.
What do you gain by having that in a separate directory? You want to separate like pieces of the app rather than technological categories, if that makes sense. It's the same type of concept as if you co-locate your style sheets, or in Relay, you co-locate your queries. You kind of want to have everything that's got to do with the same thing together, right?
Yeah, I agree. I think the challenge is like with this, like because of the very nature of it, sometimes this is a way of allowing two features to talk, almost, is like one way I like to think about it. Then like you almost need to like have your thing that's storing the state at like the one level that like groups those two, or whatever the case is. We've got Kirill in chat, and he said, put all your states in a folder called the Atoms family. There you go.
There you go.
We got to get you some shirts made with that little play on words, although I'm going to guess that you've probably heard it at least 92,000 times before I first said it.
More, I'd say closer to 92 than 92,000 realistically, but yeah. Go ahead. Because of the lag, I don't know if he said go ahead first, so I'll just go ahead. There's some other features in Recoil that we could talk about, or I don't know if you had any other questions about what we talked about so far.
Let's kick it back to you. I know Kirill had a question about release and stuff, but let's say that at the end. I want to hear. I can put your screen back up, and we can go over the other features.
Okay. Yeah, so the other thing that Recoil provides is a version of Selectors. And so a lot of people probably heard of Selectors in the context of Redux and all that kind of thing. But basically, it's just a function that is sort of subscribed to some piece of state, and then it reevaluates whenever that state changes. And then you can use the resulting value in different components. So that kind of goes along with Atoms, and it prevents you from having to have different pieces of state that really can't vary independently. Like you kind of want everything that's state to be something that can truly vary independently. And if it can't, then you're just, you don't want to have two different pieces of state, because you're inviting problems with them being out of sync and that type of thing. So just an example of that. In this app, I've got this bounding box that goes around the selection. I can actually select multiple, and I have this rectangle that hopefully is nice and clearly visible that surrounds all of the selected items. And when I move one of those items or change the selection, that box should be recomputed. If I move some other item, it doesn't need to be recomputed, right? So that's something we could implement as a function. Like, it is just a function of what is selected and what those locations of those items are, right? So we'd like to be able to think of it in a functional manner rather than as its own piece of state that needs to be kept in sync. Does that make sense?
Yes. Yep.
So we want to have a situation where instead of just having these atoms floating above the React tree, we actually have a graph, like this data flow graph of functions. So we have an atom for the selection and we have atoms for these individual items. And we want to be able to put these intermediate nodes in, which are selectors, like computing things, and then those go down into components, right?
Yep.
So the way that the code for that would look is we define something called a selector, and it has this function called get, which is going to evaluate it. And the first thing we'll do is we want to get the value of this selection atom. There's some atom that's like what IDs are selected. So we will get that selection atom. And then we want to get the state for the corresponding items. So we can just map over those selected IDs and we can get the state for those associated items. Does that make sense?
Yep.
And then we can do something to compute the value from those. And when we have that, we'll implement this selector thing, and we can export that. We'll call it selection bounding box. Just something to note is that, unlike in many systems in Recoil, this graph is dynamic. So as you change the selection, this selector will unsubscribe from some items and subscribe to other items depending on what's selected. So actually, if you go here, it doesn't really matter in this example, but if you are moving some other item that's not selected, it's not reevaluating the bounding box selector.
Yeah,
okay? Which is really, really important in certain situations. So we'll export that, and then the way that you use this selector is actually the same API that you use for an atom. So you pass in a use recoil state, and then you get the value, so you can render that out, and that's kind of all there is to it. And so it's the same API, and the implication of that is you can have something that you originally modeled as state and actually change it to be a computed function, or have something that was originally computed and change it to be state. And you can go back and forth, so you're not like stuck with, oh, this thing's state and now I can't refactor it. It makes it really easy to refactor. And so I have an example of that, which is that currently in this app, the size of each of these items is just state, so I can edit it. But what I'd like to do is take this whole family of atoms and sort of wrap each of those atoms in a selector that's going to compute some things. And it's going to support dropping a photo onto the canvas. And the size of this photo is not state. It's actually just determined by something we got from the photo itself. So I can't resize it. So I'm going to put a selector in front of each of the atoms without changing the components that says, like, if this is a photo, it should have these specific dimensions rather than that coming from the state. Does that make sense?
Yep.
So we have this item with ID atom family, which is the state for each of these items. I'm going to basically make that private, and I'm going to just rename it like item state with ID. So it's like the private underlying state, and I'm going to encapsulate that with a selector. And just like there's atom families, there's selector families. So there's going to be a separate selector corresponding to each ID, corresponding to each atom. And so when we define the get function, it gets this ID, and it's going to get the underlying state for that atom. And then it's going to just say, like, if this is an image, I'm going to compute the dimensions for that image at the particular URL and return that. Otherwise, I'm going to return the unmodified state. So far, so good?
Yeah. Yeah, I kind of like it. I kind of like the elegance of hiding this, because like the component itself, like the thing that's consuming this, like that API is super, super clean, which I kind of like about this approach.
Right, and it doesn't know that we've actually swapped out some state for a function, right?
Yeah.
There's one other trick here, which is computing the dimensions for the image for this URL is actually async, because we have to fetch the image. So all we have to do is put await in there, and I guess make this an async function, which I didn't do in the slide, but we can just await something, and then we will get this behavior where when we drag an image on, it goes and fetches the image, and then once it has it fetched, it it draws that on the canvas. But basically everything that's downstream of that selector while it's awaiting can be suspended.
Yeah, it's pretty slick.
So you could take something that was originally state, you can make it computed, and then you can say, oh, I actually need to compute that on web worker or on the server, and just move it, and your components don't really care. And then the final thing that Recoil gives you is app-wide state observation. So there's some APIs, and I won't go into the details of them. They're actually probably going to change a little bit, but you can do things that you would allow you to build like a dev tool. And we actually have this dev tool that a colleague of mine built that we hope to release very soon. I think it's in GitHub, but not yet on the like Chrome App Store and that kind of thing. That gets you a history of all the state changes, and then actually visualizes the selector graph. You can see how things are connected, and it will, the size, the width of those streams actually changes with the frequency that those selectors reevaluate. So you can see, oh, like that's a really hot selector that I need to optimize or something like that. And that'll be released soon. But the point is, this is implemented entirely with APIs that are in Recoil. So you can, if you want to implement whatever sort of meta thing that's looking at all your state, looking at your state changes, looking at those transactions, you can do that as well.
Can you, I don't think I understood what that dev tool was actually showing me. Could you bring that up one more time?
So on the left is atoms.
Okay.
And then these intermediate nodes are selectors. And it's on the screenshot, but it now also shows components that are subscribed. So you have some atom, and it's like, okay, this selector is subscribed to it, and then that. So when I change that, everything downstream of that will get reevaluated.
And what is the blue and red?
What is the blue and red? I think that is whether it is a family or not.
Okay.
Yeah.
And like, I also didn't totally follow. How would you spot something that was like problematic performance-wise?
So like this one isn't evaluating as much. This one's evaluating more frequently. Like
okay.
The width, is just proportionally how much is getting evaluated. And that's that's kind of under development, so that's not like what it's going to look like in the end. But and I think it actually I should update that screenshot, but that's the type of thing that API lets you build, the like app-wide state observation.
Yeah.
One of the things that strikes me here is just how much analysis and development you've done on this problem. Like it's quite a bit of awe here for you to dig through and build out an interesting like state management tool and also a visual debugging tool. Like, I'm sure there are like budding framework developers in the audience that want to know what they're getting themselves into. Can you talk them off the ledge? Like, did you think this was going to be like a couple of weeks worth of work and now it's like your full-time thing? Or, I mean, walk us through it here. It's a lot going on.
I appreciate that. And, there's a few people that work on it. Like this whole development tool was built by a colleague of mine. And I also put links to their GitHubs and that kind of thing. But it is kind of it's not a full-time job. It's like a kind of a side project, but it's a side project for a few people. It does kind of consume a certain amount of time and energy for sure. So that is, I guess, something you're getting yourself into if you create something that people want. But it's all just driven by necessity. Like I wasn't like, I'm going to make a state management library. I have to make a state management library. Oh no, I'm going to be one of those people. But all of the capabilities of it are like, oh, we need this for this app, right?
Yeah.
So
use case
the app that this came out of originally is a profiler. So you probably used profiler in like Chrome or whatever that measures how long things take. We built an app that is that, but it's aggregated over large numbers of traces collected in production. So basically everything that you see, instead of being a single measurement, is a statistical distribution. And so you can, and then you can do analysis on like what variables affect it. So like, is it affected by, OS, or is it this function slow for people that have a large number of friends, or, all these different type of, does this go up with a particular code change or configuration change, that kind of thing, and lets you do analysis on that type of thing, which I think that there's actually a presentation where that was shown publicly that I can put a link to when we're done.
Now, for those in the audience that may want to contribute a little bit to this project, like, do you have like an on-ramp for new contributors? Are you asking for open source contributions? And if so, what kind and how do people do it?
That's a great question. I would say we don't have a great on-ramp, and that's something we should really do better at, and that we're kind of working on. So we just recently set up a Discord and are trying to like move our chats over from Facebook stuff to Discord so that people can participate. We do have some folks outside of the company that are contributing, but yeah, I think that if somebody really has something they want to do that is you know, a significant change, it's good to kind of talk about it and see how that fits in with plans. But we would absolutely love for people to contribute. But probably the place to start is get on the Discord and start discussing the things. Of course, if it's just like a simple bug fix or something like that, then just put a pull request in. That's very, very welcome. So.
So somewhat related question, because Kirill asked this earlier. So technically the project is right now considered experimental. Is that correct? So
That's right.
Kirill was wondering when can we expect an official release? So I'm sure you can drop us a very specific date right now.
That's right.
But I am sort of curious, like, because it's experimental, like if someone watching this, like, should they put this in their production app? Should they like put it in but be careful? Like, what sort of recommendations would you have for people that like sort of like the project but are maybe concerned by just that word being used?
They should use their judgment. No, it's experimental. What that means is that it is an experiment. It's something that we're trying out. It's not like endorsed by Facebook, the company, as a thing that anybody should use, in contrast to React and Relay that everybody should use. And it may have no future. It may be a dead end, or it might evolve into something different. API could change. So any of those things could happen. And eventually, like, I think the long-term story we'd like to have is that you just use React for all of your, you know, you can handle all these types of situations. That's what I would personally like to see. However, that's not the case currently, and this is something that may be useful to you that you might try using if you want to.
Yeah, it seems like if your app is thrashing on
re-renders in production. What's that?
It seems like if your app is thrashing on re-renders, you've got a decision to make, and you know what's going to be the less of two evils.
Right. Yeah. I mean, there's trade-offs to everything. So that's kind of the state it's in. We use it for different things. It's not extremely widespread, but it's used for a number of different apps and things at Facebook. But it's not something that we'd say like, oh yeah, we're gonna like definitely support this, and you can go ahead and use it without trepidation. Yeah, definitely.
Have you tried submitting a pull request into the React framework?
I don't really want to talk about future plans.
Just say, I like this / Dave McCabe.
But you did release a new version. Actually, I think you said just yesterday, right?
That's correct. Yeah.
What are the new things that just shipped?
Yeah, so it had been a little bit, and we just released version 0.2. The biggest change in it is that we re-implemented selectors and just fixed a bunch of weird edge cases with selectors, particularly async selectors. So they should be a lot more stable and reliable now, and as well as more performant because they don't have to reevaluate as frequently in certain situations. So that's kind of a big internal change, and the result of that is probably you don't see a difference, but if you were seeing some bugs before, you may not know. And then it's also quite a lot faster if you're using large numbers of atoms. And there's still some optimization we need to do with that, but it should be a nice speed up if you are using like tens of thousands of atoms. And then there's just a bunch of like bug fixes and little improvements. Like it's now compatible with IE11 for those who need to support that, and you know, kind of miscellaneous bug fixes and things.
Exciting.
Yeah, and then we do have other stuff that we're hoping to release soon. Can't really commit to any particular time frame, but those development tools that I had the screenshot of should be out at some point. We have an API that we're going to there's kind of a half-baked API for synchronizing with external state, like if you wanted to synchronize with, say, the URL, which was part of the original design of Recoil, but we wanted to take another swing at that, and that should be out hopefully before too long, like a kind of more cohesive, flexible way of doing things like that. If you want to synchronize with local storage or something that's on the server or the URL, that kind of thing. And then actually that's something we might potentially want some help from open source, just to like test different integrations and things that people want to do. And then another feature that should hopefully be coming out very soon, that we're testing internally, is garbage collection. So currently, when you create all those atoms that are in an atom family, you have to manually delete them. And there is a change that we hope to release soon, where Recoil will, on a configurable basis, optionally delete those when they're no longer in use. So if you just were no longer referring to a particular atom, it would go away. And we're using that. It's going to have a slight breaking change to the API, so we'll roll that out over a couple of releases.
Is there
and
anything
that at that point that's kind of the biggest piece where I'm like, this is a major like missing thing. So I think we'll be in a kind of a good spot after those two things are released. Sorry, but go ahead.
I mean, I know this is pretty well sort of, I wouldn't say tied to React, but are there scenarios where you can see Recoil being used by other popular front-end JavaScript frameworks?
I would not anticipate that. It is totally tied to React, and that tight coupling is beneficial for compatibility with different React features and just consistency with React. So if anything, that'll probably just get tighter.
Fair enough.
Like this type of thing is very specific. Like if you're in another UI framework, you might not even have the same issue, or the exact way that you would want to solve it is going to be different. So I don't know that it really makes sense for this type of thing to be portable across those.
Well, cool, Dave, this has been a lot of fun. Is there anything, I want to give a last call out for Chad. If you have any last questions, you got a minute or two to get those in. And I just wanted to ask you, is there anything we haven't covered here today that you think is important, that you want people to know, that you want to get out there?
I guess there's one thing I want to mention about selectors I forgot to mention, which is that going back to the thing we talked about before, where you're splitting up your state, Recoil selectors are different from most implementations of that in that they don't suffer from that issue where you are evaluating every single selector that might need to be evaluated, right? So we just already, like, it allows you to do something that's like O1 instead of ON as far as scaling up selectors to a larger number of things. So there was actually an RFC against React that was adding selectors to context. And so that's just a thing that you actually see in a lot of apps that are using Redux and that kind of thing, where you have, like, you're picking off these individual little bits of this big blob of state. So I just want to advocate for splitting up the state into little pieces instead of doing that every update at runtime, if that makes sense.
It does.
I probably didn't explain that in the most straightforward way, but that's kind of the approach that I think makes this better than some other systems along those dimensions.
I'm actually curious. I'm wondering how can it determine which selectors it needs to re-render? Like, how is it because it's derived state?
Because they're only subscribed to the specific atoms. It's just a consequence of splitting things into atoms, as opposed to using selectors to like focus on parts of a large object. Does that make sense? Which is how they're often used. It's like, I have this big thing and then I'm selecting out a slice of it. Like, don't do that. Just already have the slice pulled out.
Yeah. So because your selectors are coming from those derived atoms, you almost have like a more granular ability to know.
Right.
Well, these things change. Like exactly. That map you showed in the debugging tools, you can sort of trace a line to minimally update things. Okay.
Yeah.
It took me a second, but I got there.
It's the same principle that powers React. Is like, the component that the particular state is associated with. So this is just taking that to other situations.
Cool. Well, we got one nice comment that came in from chat. Flutter1 says, Recoil is so nice. I made my own version of his demo app last year, and it was so easy dealing with state. So you've got some fans in the chat as well.
There is a link to a nice course if you want to build the demo app, or if you want to kind of get walked through that if you go to the recoiljs.org website and click on external resources, there's a link to something Jack Blom, I think is his name, made, and it's a free video course where it walks through building that same app, and it's really nicely done.
Oh, nice.
It's dropped that in the chat, and actually that's probably a pretty good segue, because one thing we like to end with is if you give us like any sort of like link dumps, where's the best place to follow you? Where's the best, like anything else you think people should know, like links, getting started, anything like that? Now's a good time to.
Yeah, it's all
drop
on
those.
recoiljs.org.
Okay.
And then my Twitter is MCC_ABE. There's a Recoil official Twitter, Recoil.js. And I can grab some other Twitter handles and paste them in the chat, or I don't want to. I'm probably still sharing my screen, so I should stop that.
I've got the screen out. Yeah, if you drop them in the private chat here, I'll push them into the public chat. But I've got Recoil. I've got the video course you pointed out. Your Twitter, the Recoil Twitter. So those are all in chat if people want to check those out.
Cool. Yeah, I think that's it. I'm trying to see here if anybody else has a Twitter who works on Recoil, and I don't see that. So
isn't that crazy? What year is it, people? Get a Twitter account.
No, it's the people that are on Twitter that are crazy.
There's a bit of that. I couldn't even imagine.
Well, cool. Yeah. While you're looking at that, Dan.
Sorry, go ahead.
Yeah, I was just gonna say, we'd like to drop a couple other links in here to wrap up. Dan, you want to drop yours while he's looking into that?
Yeah, I'll plug an Enterprise React newsletter one more time. We get all the articles submitted by our development staff, and so they're developer approved.
So I'm going to drop the newsletter in the chat, and then I'm also going to drop the React Wednesdays homepage once I get the URL here. Again, if you were interested in this, we like doing this every Wednesday. We just bring on cool people. They teach us interesting stuff like Recoil. So thanks again, Dave. This was a lot of fun. I definitely learned quite a bit. I didn't realize there was that much to Recoil, and I'm looking forward to the debugging tool as well.
Great. I hope to get that out to you soon. And thank you so much for having me. It's been really fun and an interesting conversation. So best wishes to both of you. And yeah, thanks again.
Likewise, sir. It's been amazing.
All right. Thanks, everybody. Until next week.
Have a good day.